Look up into the night sky. Let your eyes adjust to the darkness, and you'll see a tapestry of stars stretching from horizon to horizon. For thousands of years, humans have gazed upward, searching for meaning, for patterns, for a sense of our place in the universe. Beyond the city lights and the familiar glow of the moon, there's a vastness that's easy to forget in our daily lives. The city's brightness hides the true depth of the cosmos, but above it all, the universe continues its silent dance. Out there lies an ocean of blackness, dotted with the ancient light of countless stars. Each pinpoint of light is a messenger from the past, traveling for years, centuries, or even millennia before reaching our eyes. Each star may have its own planets, some rocky, some gaseous, some perhaps with oceans or atmospheres. Astronomers now believe there are more planets than stars, each one a potential cradle for life. Our Milky Way is just one of billions of galaxies, each a swirling island in the cosmic sea. Every galaxy contains billions of stars, and the numbers quickly become almost unimaginable. This vastness has always inspired wonder and a haunting question. With so many worlds, so many chances, where is everybody? Why does the universe seem so empty, so silent, despite its age and its abundance? This is the Fermi Paradox, the puzzle that has haunted scientists and dreamers alike. If the universe is so old and so full of planets, why don't we see signs of other life? Why haven't we heard a single message or seen a single unmistakable signal? We expect a chorus of signals, a cosmic conversation echoing across the void. But all we hear is silence, an endless, profound quiet that stretches across the light years. Are we truly alone? Or is there something fundamental we're missing about life in the cosmos? Is the silence a sign of our isolation, or a clue to a deeper mystery we have yet to unravel? For generations, many have concluded that life is a rare fluke, a cosmic accident, a brief spark in an otherwise empty universe. Others have wondered if civilizations rise and fall, leaving only faint traces behind. But what if the silence isn't absence, but the prelude to a discovery we're only beginning to understand? Perhaps the universe is waiting for us to listen more closely, to ask better questions, and to open our minds to answers we never expected. Science has often likened life's emergence to winning a cosmic lottery. Earth just happened to draw the lucky numbers. Our existence, in this view, is a beautiful accident in a universe of missed chances. But a new idea is gaining ground. What if the universe is wired to build complexity? Some scientists now argue that life is not a fluke, but a natural outcome of the laws of physics and chemistry. The universe, they suggest, has a built-in tendency to create order, from atoms to living beings. If true, we're not a miracle, but an expectation, a product of a universe that builds. This idea could change how we see ourselves and our place among the stars. The second law of thermodynamics tells us that the universe, in its grandest sense, is always moving toward greater disorder, a concept known as entropy. Over time, things naturally fall apart. Buildings crumble, fruit decays, and even the pages of old books yellow and fade. This law seems to suggest that chaos is the ultimate fate of everything. Yet when we look around, we're surrounded by astonishing examples of order and complexity. Forests burst with life, our brains orchestrate thoughts and memories, cities pulse with organized activity, and flowers bloom in perfect symmetry. These are not just random accidents, they are intricate systems, each more remarkable than the last. So how is it possible for such complexity and beauty to arise in a universe that's supposedly destined for chaos? How do cities rise from wilderness, stars ignite from clouds of dust, or snowflakes form with such delicate precision? Some scientists believe the answer lies in the flow of energy. While the universe as a whole moves toward disorder, the movement of energy, like sunlight streaming through leaves or rivers flowing downhill, can create local pockets of order. These flows drive the formation of patterns, structures, and even life itself. Think of a river carving a canyon as it rushes toward the sea. The process of dissipating energy doesn't just destroy, it can also build. Over time, the relentless flow of water sculpts intricate landscapes, shapes sand dunes, and even helps seashells form on the shore. Life is perhaps the most extraordinary example of this phenomenon. Powered by the sun, living things harness energy to grow, adapt, and reproduce, temporarily defying the pull of chaos. Plants turn sunlight into food, children play and learn, and every leaf is a tiny engine of order. The second law isn't wrong, it just doesn't tell the whole story. It describes the overall trend, but not the fascinating details of how order can emerge, persist, and even flourish in certain places and times. Along the way to disorder, complexity can and does arise. Ice crystals form and melt, Ants build elaborate colonies, and cities light up the night. All temporary, but all real. The real puzzle is deeper. Why does the universe seem to favor certain kinds of complexity? Why do peacocks grow such elaborate feathers? Galaxies spiral into beautiful shapes, or bees build perfect honeycombs. What makes some forms of order not only appear, but persist and even grow over time? This is the mystery at the heart of our universe, a story of chaos, order, and the surprising ways they intertwine. To truly grasp how complexity arises in our universe, we need to introduce a powerful concept: functional information. This idea helps us understand not just how things are arranged, but why certain arrangements matter more than others. It's a way of measuring how much information is required to achieve a specific function or purpose, and it's at the heart of how order emerges from chaos. It's not just about recognizing patterns or seeing order for its own sake. What really matters is when those patterns actually do something useful, when they serve a function, solve a problem, or make something possible that wasn't before. Functional information is about the difference between random arrangements and those that achieve a goal. Think of a random splash of ink on a page. It's just a mess, meaningless and without purpose. But if those same marks form a sentence, suddenly they tell a story, convey an idea, or spark an emotion. The difference isn't in the ink itself, but in the arrangement that creates meaning and function. The universe seems to favor order that serves a purpose. We see this everywhere, from the intricate patterns in a beehive to the organized flow of traffic in a city at night. These aren't just pretty designs, they're arrangements that help living things survive, thrive, and adapt. Imagine you have a pile of random keys and a single lock. Most of those keys are useless for that lock, no matter how shiny or ornate they are. Only a very specific key will open it. Most keys won't fit, but one might open the lock. That's functional information in action. It's the knowledge of which arrangement works, hidden among countless possibilities that don't. Evolution works in a similar way. Through endless trial and error, nature tests countless combinations. The ones that unlock new possibilities, like a mutation that helps an animal survive, are kept and built upon. Over time, this process accumulates functional information, leading to ever more complex forms and behaviors. When atoms come together to form a stable molecule that can absorb sunlight, that's a new function, a building block for even greater complexity. Each new function opens doors to more possibilities, setting the stage for life and everything that follows. Nature, through selection, remembers what works. Successful solutions are preserved while failures fade away. This memory is encoded in the very structure of molecules, organisms, and even societies. Functional information explains how order can emerge from chaos without breaking any physical laws. It's not magic. It's the result of countless experiments, with the winners shaping the world we see. The universe is constantly trying out new combinations, like an inventor tinkering in a workshop. Most ideas don't work, but the useful ones stick around, becoming the foundation for future innovation and complexity. This principle of functional information may be the driving force behind the creation of everything, from the birth of stars and galaxies to the emergence of living cells. It's the hidden thread that weaves simple beginnings into the astonishing complexity of our universe. We see this principle at work everywhere. After the Big Bang, the universe had only hydrogen and helium. Stars forged heavier elements, carbon, oxygen, iron, building new tools for creation. On early Earth, life's arrival transformed geology. Photosynthesis released oxygen, triggering a revolution in minerals and complexity. Life and the planet evolved together, each driving the other's complexity. In labs, scientists mimic early Earth, watching simple chemicals form complex chains, some with lifelike behaviors. These experiments show that complexity can arise naturally, given the right conditions and time. Across the cosmos, simple systems plus energy and selection evolve toward greater complexity. The universe builds on its successes. Carbon from stars becomes life, minerals shaped by oxygen become new structures. Complexity builds on complexity step by step. This is a universal trend, not a cosmic accident. Complexity doesn't grow smoothly. It leaps like climbing floors in a building. Atoms formed from particles, stars forged elements, molecules became planets, and on Earth, life began. Each leap unlocked new possibilities: multicellular life, nervous systems, consciousness. Each floor provides a platform for the next, more elaborate one. Before multicellularity, life was limited. After, diversity exploded. The universe surprises itself. Each new level brings properties unimaginable before. This stepwise process suggests a direction, not toward a specific goal, but toward increasing functional information. The universe explores what's possible, and each innovation becomes part of its toolkit. We stand on a floor built by billions of years of cosmic construction. The stairway of creation is still rising. Is complexity inevitable or just a lucky accident? Scientists are divided. Some, like Hazen and Wong, see universal laws of complexity at work, connecting physics, chemistry, and biology. They point to convergent evolution, like eyes evolving independently, as evidence that nature finds similar solutions again and again. This suggests a deeper predictability in evolution. Critics argue that functional information is too vague, and that life's history is shaped by chance and catastrophe. If a single asteroid had missed Earth, dinosaurs might still rule. For them, evolution is a chaotic branching tree, not a predictable stairway. The debate is healthy, pushing both sides to seek stronger evidence. Is complexity a cosmic law or a cosmic fluke? The answer shapes our understanding of life's place in the universe. This debate has profound implications. If complexity and life are inevitable, the universe could be teeming with life, we just haven't found it yet. Maybe we're listening for the wrong signals, or the distances are too vast. Life might arise wherever conditions are right, as predictably as crystals form. Alien life may not look like us, but could be built on the same principles of energy and information. If complexity is universal, our own technological evolution may be the next step on the cosmic stairway. We could be part of a process far larger than ourselves, a universe building ever more intricate systems. We are not just observers, but participants in the cosmic story. So we return to the silent, star-filled night. The emptiness may be full of promise, not loneliness. Complexity as a universal feature suggests a cosmos engaged in ongoing creation, not by design, but by natural law. The blueprint is written in physics and chemistry, driving the universe toward ever more elaborate forms. We are not a miracle, but the result of creative evolution as fundamental as gravity. We can trace the chain from the Big Bang to conscious beings who now ponder their origins. We are the universe becoming aware of itself, part of something immense and wonderful. Perhaps we are not a lonely accident, but inevitable. And that is a thought of breathtaking significance.